Awesome. Awesome. Hello, everyone. Welcome, welcome, welcome. So we're about to go over the notes for today for 2.1. So we just went over the do now. We just went over the do now and then the think, pair, share question. So now we're going to go into our notes. And you will need your notebook. So if you have your notebook, please take it out at this time. But let's get started. I'm going to put 7 minutes on the clock for me. Boom, boom. Awesome. Now, I just started my time. So two things we're going to go over is kinematics. And kinematics is the study of motion. And two main forms of kinematic vocabulary words that we'll be going over is scalar and another word called vector. Vector. Okay? Scalar and vector. Now, let's think about these characteristics of what they are, okay? What are these things? What's a scalar? Well, a scalar is a quantity. So they're both quantities. So let me just specify. They're both quantities. So, but this one is a quantity. A quantity of only magnitude. So how big or how small it is, it's only a quantity of magnitude. While vector is a quantity of both magnitude and direction. So not only how much or how little it is, but what direction is it going? What direction is it going? So that's the difference between a scalar and a vector. So automatically, a scalar has no direction. No direction. It has like no direction at all. Okay? Another thing we know about scalar is that it's only in one dimensional. Only 1D. One dimensional. That means it can only exist on a flat surface. That's it. Like a little dot. That's all it is. As opposed to vector, vector can exist in 1D, 2D, or 3D. It exists in 1D, 2D, or 3D. So one dimensional, in two dimensionals, or in three dimensionals. Okay? Scalar also has exact values. Exact values. It never changes. It never ever changes. Okay? It never ever changes. As opposed to a vector can be solved in any direction. Okay? Can be solved in any direction. Okay? Can be solved in any direction at all. Okay? Give a couple more seconds for that. The last thing I want to put is that the way you label it for scalar is just like a little V right there. And for vector, it's a V with an arrow on top to show you direction. So a scalar will only be identified like a little symbol, while a vector will have a symbol plus an arrow at the top. And that arrow tells you that it's going a specific direction. That's how you can tell the difference between a scalar and a vector. If it has an arrow on top, it's a vector. If it doesn't have an arrow on top, it's a scalar. Okay. Okay. A couple more seconds to write that down, and we'll move to the next one. Okay. These notes will be posted later on, so no need to worry if you haven't copied it down yet. Okay. So let's go. Let's be more specific now. Let's go with scalar. Let's go with some examples. Scalar versus vector. Okay. What are some examples? Well, let's do some examples for scalar, right? For scalar, let's say we have 30 meters. Let's say we have 100 degrees. 100 degrees. Let's say we have 600 kilograms. Let's say we have 30 cups. Now, none of these have directions. They just have magnitude, meters, 30 to 100 degrees, 600 kilograms, 30 cups. Well, 30 meters where? 100 degrees of what? 600 kilograms of, what we need specifics, right? We need direction. So how a vector will make this better is that it's not only 30 meters, but maybe it's 30 meters north. Okay. And then maybe it's 100 degrees, but not just any 100 degrees. Maybe it's 100 degrees to the left. See? Let's say maybe it's not just, let's do another one. Let's do like 75 joules. Joules is energy. Well, 75 joules of what? 75 joules forward. Oh, actually, this should have been different. Forward. And how about, let's do the last one, like 30 cups or like 600 kilograms, sorry. 600 kilograms. And let's say it's had 600 kilograms with an arrow on top. And automatically that arrow tells you that it's a vector. Like that. Okay. Get a couple more seconds to write it down. How about 1 more minute? And then we'll go into the last part. Okay. Let's go into the last part real quick. The last part is on a graph. Oh. Since we'll be using a graph a lot, on the graph, a scalar is basically, like I said, it's just one dimensional. So basically, it's just a dot. See, scalar, just like 1 point. As opposed to a vector actually has direction. So a vector has direction. So in the graph, that's how it will look. Okay. So for scalar, as a dot, that's where it is on the graph. And for vector, it's actually an arrow pointing direction. Okay. Give you a couple more seconds for that. Okay. Well, let's check out the guided practice. So I have the conclusion right here of the notes in case you need to check them out. But let's go to guided practice, okay? It says, to test your understanding of scalar and vector, consider the following quantities/pictures listed below. Categorize each quantity as being either a vector or a scalar. 2 of them have been done for you. So I've already done 2 of them. 5 meters is a scalar because it has no direction. And 20 degrees Celsius is also a scalar because it has no direction of a specific area. Are you going 20 degrees Celsius up? Are you going 20 degrees Celsius lower? It has no directions. So I'm going to give you guys 3 minutes for my ones on the Zoom session, 3 minutes to fill out this table, and then we'll go over it together. Okay. We're going to do 3 minutes of that. Awesome. So let's go over the guided practice. So we know the first one is the scalar because it just does 5 meters and there's no direction. So it just shows magnitude. So it just shows it's 5 meters, but 5 meters in what direction? So we know that one is a scalar. For the second one, would there anyone on my Zoom session students, my synchronous students, would anyone like to answer that? 30 meters per second east. Would that be a scalar or would that be a vector?
Vector.
Awesome. Thank you so much, Sarai. It'll be a vector. And Sarai, do you think, can I push you a little bit more? Why do you think it's a vector?
Because it tells us the direction.
Awesome. Thank you so much, Sarai, for that complete statement. It's a vector because it tells you direction as well. So not just only magnitude, but direction. Thank you, thank you, thank you. The next one is a picture. It's not words, but it's a picture, but it does have something specific on it, right? So what will the next one be? This little picture right here. Would this be a scalar or would this be a vector? You can come off mute and share, or you can type it in the chat box.
A vector?
Can you be more specific on that one, Ruby? Why would it be a vector?
It has the arrows.
Yeah, good job. Thank you for that complete statement. It's a vector because it has the arrows. So actually showing direction of the wind speed and direction of the airspeed. Thank you so much. On the next one, 5 miles north. So this one will be a vector or will it be a scalar?
A vector.
Vector.
Awesome. Thank you, Sadia and Zerai. Zerai, can you be more specific? Why would that one be a vector?
Because it's being specific.
Good job. It has direction as well. So you gain the hang of it, vector and scalar, right? Thank you so much. How about the next one? Next one, this one just says, it's a, like a box, and it has the word volume on it. So will this one be a vector or would this one be a scalar?
A scalar because it's not telling us like a direction or it doesn't have like an arrow.
Awesome. Thank you so much, Sadia. Yes, there's no arrow, there's no direction. It just says volume, just magnitude. So basically, yes. And then we'll go for our next ones. Now you get the hang of it. 256 centimeters to the left. It says left, so left has direction, so that one's a vector. The next one is a graph, and the graph actually shows an arrow of a direction of that A arrow. That will also be a vector. Oh, a vector. And the last one is 4,000 calories, but we don't know 4,000 calories of what. Did we add 4,000 calories? They would go up. Did you lose? What were we talking about? So this one's just a scalar. It has no direction whatsoever. So yes, so this is the guide practice right here. Give you guys a couple more seconds to write that down. I'll stop right here. Awesome. So that is pretty much it for today's assignment since today is Monday. If you scroll down, here's our objective again. Physics will differentiate between a scalar and a vector quantity by comparing and contrasting various examples, which we have. So hopefully you know what a vector is and what a scalar is. For today, as in Monday, you have one thing to complete, and then make sure you post the Think, Pair, Share question on Piazza. So make sure you post your question on Piazza. You post the answer to it. It's right here. I've already had some scholars who have answered it, so thank you to my two students who have answered it so far. But that's your assignment for today. Okay, so that's pretty much what we have for today. So make sure you do the assignment, and tomorrow make sure you post the response to the 2.1 Think, Pair, Share question. And then that's pretty much it. That's pretty much it for today. Hope you guys have a great day. Adios.